assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Okay, so for this problem, we have a pendulum that consists of a disc with a radius of 10 centimeters and a mass of 500 grams attached to a uniform rod with a length of 500 millimeters and a mass of 270 grams. The first thing we are trying to find is the rotational inertia of the pendulum about the pivot point. So there's three things that are happening here. So there's three different moments of inertia that we are going to have to calculate in order to find the total inertia. So the first portion is the inertia of the disc itself rotating about its center. And so we're going to calculate that inertia. We'll have that as be inertia 1, which is going to be 1/2 the mass of the disc times the radius squared. The second portion is the fact that the disc is rotating a distance of the radius plus the length of the arm. And so we're going to calculate the inertia of that portion, which is going to be the mass of the disc times the length of the arm plus the radius squared. And then finally, there is the inertia of the arm itself, which has a length of L, and it has its own particular mass. And so we're going to calculate that as 1/3 the mass of the rod times the length times its length squared. And we're going to add all of these together in order to get our total inertia. But first we want to change our grams here into kilograms. So we have 500 grams, which is 0.5 kilograms. And we have 270 grams, which is 0.270 kilograms. And we also are going to want to convert our distances here. So our radius is going to equal 0.10 meters, and the length of our rod is going to equal 0.500 meters. So when we combine all of these together, we get that our inertia equals 1/2 times 0.5 kilograms times 0.10 meters squared plus, we once again have our 0.5 kilograms times both lengths, so we have the 0.10 meters plus the 0.500 meters, and that's going to be squared, plus finally 1/3 the mass of the rod, which is 0.270 kilograms, times the length of it, which is 0.500 meters squared. And when we do all of that math, we get that our final inertia is 0.205 kilograms meters squared. We're now being asked to determine what is the distance between the pivot point and the center of mass of the pendulum. So if we let the pivot point be the origin, and the distance between the center of mass and the pivot point is then going to be the length of the rod divided by 2, which in this case is 0.500 meters divided by 2, or 0.250 meters. So that's our new length that we're going to be working with. That's the to find our distance. The distance between the center of the disk and the pivot point is going to be the length of, so the length to the disk is going to end up being our radius, which is 0.10 meters, plus the length of the arm, which is 0.500 meters, which gives us a total of 0.600 meters is the length of our disk. And we're going to use the following equation. The distance that we are looking for, the distance between the pivot point and the center of mass, is going to be the mass of our disk times the length to the disk plus the mass of the rod times our new mass here, which we can just call this one length of center of mass for the rod, divided by the mass of our disk plus the mass of the rod. So when we substitute in our values, the values we have distance equals 0.500 kilograms times 0.600 meters plus 0.270 kilograms times 0.250 meters divided by 0.500 kilograms plus 0.270 kilograms. And we get an answer of our distance between the pivot point and the center of mass comes out to be 0.477 meters. The very last part of this problem is finding the period. And usually you use the equation period equals 2 pi times the square root of inertia divided by mass times gravity times length of the center of mass and the pivot point, the length between the center of mass and the pivot point. Ours is going to be a little bit different simply because we have two masses. So ours is going to be inertia divided by our mass of the disk plus the mass of the rod times gravity, and the distance that we just found is going to be the length of that we're going to use. Instead, we're going to use the distance that we just calculated. So substituting in our values, we have our period equals 2 pi. Now for inertia, we found that inertia was 0.205 kilograms meter squared. And we're going to divide that by the mass of the disk, which is 0.500 kilograms, plus the mass of the arm, which is 0.270 kilograms, times gravity, which is 9.8, times the distance, which we just calculated, which was 0.447 meters. And when we do all the math, we get that our period equals 1.50 seconds.